working on completing the square. Our objective is to use this method to solve quadratic equations. Alright, so to use completing the square, we first need to make sure that we have the two most important terms, the x squared and the bx term. At least if you have these two, you can use the method that we're working on today. In addition to that, the leading coefficient must be 1. Okay, alright. The reason it should be 1 is because if it were other than 1, you'll have to divide the entire equation, every single term, by the leading coefficient until it becomes a 1. Alright? So for now, let's go through the process of completing the square. To complete the square, we need to have the two terms we mentioned, x squared and bx, where we need to add, for the third term, to create a trinomial, okay, we need to take the b value, the middle value, divide it by 2, and then square that. Whatever result we get will be added to the expression to create what you call your perfect square trinomial. Do you guys remember this? Yep. Your perfect square trinomial is going to be a trinomial, which can be written down in the factor form, where you can square the factors. So let's take a look at this example on the next column. I have the given x squared plus 6x, where we need to find the third term. We need to complete the term, so completing the square, so that we can create a perfect square trinomial and express it as a factor. So in order to do that, we take the middle value, 6, just 6, not 6x. We divide it by 2, and then we square it. So step by step, 6 divided by 2 is 3, and then you need to square that number, so 9, right? Okay, what you have right here is a perfect square trinomial. However, you need to make sure that you are actually producing a perfect square trinomial. So to check that, okay, you can rewrite this so that its factors are going to be x plus 3 and x plus 3. And that's how you know you followed your procedures correctly. So let's take a look at a few examples and apply what we just learned. You take the b term, you divide it by 2, square that, and then add it as a third term. Okay, all right, let's try this out. So in this given, we'll take the b value, which is 10, we'll divide it by 2, like so, and then we're going to square it. So 10 divided by 2 is 5. However, it needs to be squared, so this results in 25. So our perfect square trinomial is actually x squared plus 10x plus 25. Notice that this is the 25, this square. We've completed the square. Now we're also instructed to rewrite the given trinomial as factors. Because it's a perfect square trinomial, you have the option to rewrite this as x plus 5 multiplied by x plus 5, or as a single factor written down with the power instead. Okay, and it doesn't matter which way you write it down, but in this case, since we're working on completing the square method, please make sure you use the second one, where you have the power. Okay, all right, let's try the next example, b. All right, we take the middle term, the middle value, -9, and it's okay if it's negative, because we're going to square this value anyway. We'll divide it by 2, and now we're going to square it. So first of all, some of you will get a decimal. I do not encourage you to use a decimal at this point. Leave it as a fraction so that you don't need to convert anything. This is what I mean. So we're going to square this, remember? So -9 multiplied by -9 is 81, positive right now. And 2 times 2 is 4. All right, notice how we got 81 over 4? This is actually already the third term. So that now you have a perfect square trinomial. See that? This was the third term. We've completed the square, producing a perfect square trinomial. Now let's write your factors. And this is the reason I asked you not to find a decimal equivalent. All right, so let's write the factors. The factors will look like this. Again, we said it's going to be written down in two forms if you wanted to. So x minus. Now, the question is, what will we put here? Go back to the example you worked on previously. Notice how we placed 5. What were the 5s from, or where were they from? They were actually the square roots of this number, or essentially the b value divided by 2. You see this? All right, so in this case, we're actually just using the b divided by 2 value, which is 9 over 2. And we'll copy it down here, like so. All right, so that's one way to write your factors, or x minus 9/2 quantity being squared. And so you can rewrite your answers in this manner. So this is what it means to complete the square. It allows us to create a perfect square trinomial so that we can write the factors, or we can write the factors out. Okay, let's take a look at the next page now. On this page, what we will be doing is, now that we're familiar with completing the square, we will apply this method in order to solve quadratic equations. Now in the past, the ones you did just a while ago, they were just expressions. But right now we will focus on equations. Now there are 6 steps, and these are just guides for you to follow. You don't need to list them down one by one every single time. Alright, so let's start. So step 1, you must write the equation in the given form. Notice that it's almost very similar to our standard form. However, if you remember, we were only able to use completing the square because you had the x squared and the bx term. Notice how we didn't use c in the past, okay? So in this case, if you have an equation, the c term, the third term, the one without a variable, needs to be alone on the other side of the equation. Step 2, we actually find b divided by 2 and square it. Step 3, because it's an equation, if you're adding the b over 2 squared to one side, you need to add it to the other side, both sides of the equation. You want it to be balanced. Okay. Step 4, make sure you have a perfect square trinomial. Then you can factor this. Step 5, continue solving by getting the square roots of each side. And then step 6, you will produce 2 possible answers where you'll have to solve each of the x values. All right, so let's see that in an application right here. I have the given example, x squared plus 14x equal to 15. Let's write the equation in the form given to us. All right, so check. Is it in the same form? Yes, it is. If so, there's nothing else to do on step 1. We've done step 1. Let's move on to step 2. Let's actually find b over 2 and square this value. In this case, we take 14, divide it by 2, and we will square that. So we're going to produce 49, yes? Okay, so moving on to step 3. We are now in step 3. Step 3 says we need to complete the square by adding the same value to both sides of the equation. All right, so let's go ahead and copy the equation we have, x squared plus 14x plus an unknown, right? And of course, because it's an equation, you want it balanced. Whatever you add to the left, you also add to the right. In this case, it appears that the value we're adding is 49. And we're also adding it to the other side of the equation like so. That okay? All right. So right now we completed step 3, balancing the equation. Step 4, we should be able to factor this perfect square trinomial right here. This is a PST. You guys remember? All right, let's factor it out. What's the square root of x squared? It's x. And the square root of 49 is 7. Because it's addition, we place addition, and then you square this. Okay, so the reason, you're going to see the reason shortly why I'm asking you to leave your answer in the square form rather than the 2 factors, okay, is equal to 15 plus 49, which is 64, like so. So we just completed step 4, factored the trinomial. Heading to step 5. Now, let me rewrite step 5 right here so we can see it better. In step 5, we're instructed to take the square root. The reason we're taking the square root at this step, which you did in the previous lesson, is so that you can eliminate the square or the power, which allows you to grant, or which allows you access to the x variable. All right. And of course, when you're getting the square root, you take the positive and negative signs, or plus minus. Okay. So x plus 7 is equal to positive and negative, and the square root of 64 is 8. At this point, we've completed step 5. Heading to step 6. Because there are 2 possible answers, right? Because of the plus and minus, we need to set 2 scenarios where each of the equation will be equal to each of the answers. So x plus 7 will now be equal to negative 8. On the other hand, x plus 7 will be equal to positive 8. And it doesn't really matter if you put the positive 8 first, as long as you have these two. Okay? Alright, continuing. So x plus 7 equal to negative 8. When we solve for x here, it will be negative 15. On the other hand, we solve for x will be 1. So then, this proves that there are, in fact, two answers because of the plus minus 8, and allowing us to find the actual zeros, or the x values. So we say the solutions are, okay, let's write it down. The solutions are negative 15 and positive 1. There you go. So if you were to try and graph this equation right here, first of all, you write it in standard form. If you were to graph this, you can go ahead and try this out. Okay, I'm rewriting this in standard form. If you did this, you graphed it, you should be able to see that the zeros are found on negative 15 and 1. Or if you used factoring, the factors you would find would be x plus 15 and x minus 1, where the zeros are going to be negative 15 and 1 respectively. Okay, so these are just the different methods to solve quadratic equations, and you can use them in specific situations as well. Alright, let's go ahead and try another example. Next page. Okay, right here. So we're still solving by completing the square. Let's try this out. Right now, okay, we're going to look at the equation x squared minus 2x minus 2 equal to 0. However, we notice that the third term should not be here. Instead, it should be on the other side of the equation. Let's start with that. So let's rewrite this as x squared minus 2x, which is now equal to positive 2. There we go. So now this will help us start with step 1. Let's go ahead and move to step 2. In step 2, we take the b value, negative 2, divide it by 2, and we square that number. Alright, this results in negative 1. When squared is positive 1. We have completed step 2. Step 3, let's actually add this value to both sides of the equation. X squared minus 2x plus 1. Alright, also on the other side, 2 plus 1. We completed step 3. Let's move on to step 4. Factor the perfect square trinomial. The factors for the given trinomial are x minus 1 squared equal to 3. And this is really, really interesting. Your steps will be very repetitive, right? Okay, we've completed step 4. Let's move on to step 5. In step 5, we will take the square root so we can eliminate the power and also be able to have access to the x variable. Alright, we're taking a square root, taking a positive and negative sign. Okay, and this allows us to eliminate the power. So we're left with x minus 1. Okay, think about this. Do you think 3 is a perfect square? No, it's not. Alright, because it's not, I do not want you using a calculator at this point. It's not necessary. You can leave it as root 3. Alright, the reason is that if you were to try and factor root 3, right, or just 3, what are factors of 3 anyway? Okay, so 3 and 1, right? Well, take a look at these two factors for 3 and 1. Can you further factor these out? No, not really. Well then, because they're not factorable or any further factorable, you say that this is already in its prime form, so we don't need to find the other factors. So let's leave it as plus minus root 3 for now. Okay. Otherwise, had your answer been root 8, you will have to factor this out because you know it's not prime yet. And root 8 will have factors of 4 and 2, where of course you know the square root of 4 is 2, correct? However, that's just one side. So root 8 is actually 2 multiplied by root 2, the remaining factor. And this will be the simplified form of root 8. You see the difference? Okay. So when you know you can factor further, you must factor further. Alright, anyway, moving forward, we found again that there are two answers. There's a plus root 3 and a negative root 3. We are now done with step 5. In step 6, we can create the two cases, or the two possible answers. Case 1 and case 2. Now, remember, these are just labels I'm putting so that we can distinguish the two possible answers. Okay? Alright, so x minus 1 equal to negative root 3. and then x minus 1 equal to positive root 3, like so. And because it's a square root of 3, okay, we are not able to combine it with 1. So we'll just copy positive 1 since we're moving it over, moving over, right? Okay. Positive 1 minus root 3 is one answer. And the other answer must be positive 1 plus root 3. Okay, so notice how they almost look the same. But because of the signs, this distinguishes them as two unique answers. Very cool. All right. So those are the solutions to the given problem. Let's try and look at another one right now. All right. So for this example, we're going to apply the same steps, use completing the square to solve the equation. So let's start by identifying, okay, that the leading coefficient is not -1. So not positive 1 rather. In that case, as mentioned earlier, we have to divide the entire equation by that number so we can eliminate it. So in this case, we will divide the entire equation by -2. Let's do that right now. So the first term will be positive x squared. The second term will be -6x. The third term will be positive 10, like so. All right. So this is a great way to start. We're trying to make sure that your equation will look like this right here, x squared plus bx equal to c. Remember? Okay, so let's go ahead and continue. From here, we need to set it up so that 10 is isolated on the other side. So this x squared minus 6x is actually equal to -10. Now we're ready to proceed to step 2. All right, step 2, take the middle term, divide it by 2, and square the number. So in this case, I'm getting a -3 when squared equal to positive 9. All right, so let's go ahead and write this out right here. So we've completed step 2. Step 3, complete the square by adding the number. X squared minus 6x plus 9 is equal to -10 plus 9. All right, so far looking good. Next, step 4, factor the perfect square trinomial on the left side. The given will have factors x minus 3 quantity squared, which is now equal to -1. Awesome. All right, so we completed step 4. Step 5, take the square root of both sides. All right, so let's rewrite. I'm going to go ahead and take the square root of each side, and then knowing that I need to take a positive and negative sign. All right, however, I'm going to have some issues here. The square root of positive 1 is not equal to the square root of -1. Don't assume they will be, because in this case, you're looking for a square root specifically of a negative number. And when you do that, it results in what you call the imaginary numbers. Okay, imaginary numbers will allow you to get the square root of any negative number. However, because we're not there yet, okay, and there's no way for us to get the square root of a negative number, even if you try using your calculators, it will give you an error, syntax error, okay? Because of that, we say that this problem will produce an imaginary answer. So we say that there are no, okay, so there are no real solutions because the answers are going to be what you call imaginary. And we'll get there. Eventually we'll get there, especially in the next few years. Okay? For now, when you get a square root of a negative number, you can stop from solving right here and say that there are no real solutions. Okay? So I'll stop at this point. Please take note of the steps in solving equations by completing the square. If you have any further questions, list them down and we can discuss them further during our meetings. Okay? I'll see you really soon. Bye for now.